So today we are going to solve a problem in Imo2024, which is placed in problem 4, and it is a geometry problem, relatively easier than the other question. So yeah, today we are going to solve this problem, and first we take a look at the problem. From the problem, we can know that I is the center of the triangle ABC, and omega is its circle that is tangent to all the sides of triangle ABC and also in the interior of triangle ABC. So according to the locations of point X and Y, we can denote the points of tangency as F and E respectively, so that just as the point marked in the picture, we can see that the line Fx is parallel to the side AC, and also the line Fx is tangent to omega. So yeah, in the same way, YE is parallel to the side AB, and it is also tangent to omega. So yeah, these are all about X and Y. And also, the line AI intersects the circumcenter of triangle ABC at another point P. So yeah, it is easy to know that AI is the angular bisector of the angle BAC. So we can easily know that P is the midpoint of the arc BC, the minor arc of BC. So yeah, and also L and K are the midpoints of AB and AC. So from the midpoint, if we connect the 2 points K and L, yeah, we use dash. We can see that KL is parallel to BC. Oh no. KL is parallel to BC. Yeah. This is the information that we got from the problem. So the problem asks us to prove that the angle KIL plus angle YPX equals to 180 degrees. So here is the angle KIL, and here's the angle YPX. So from the problem, 180 degrees, we can think of these number. It might have something to do with like the sum of the triangles angles, all the angles. Yeah, the 3 angles, their sum in a triangle is 180 degrees. So we can try to turn these 2 angles into the 3 interior angles of one certain triangle. So if we have to turn the angle KIL into another angle. So we notice that the ratio of like AL over AB equals to AK over AC equals to 1 over 2. So if we want to find one triangle similar to KIL, so we have to find another find another point. For example, it is Q. Maybe Q is here. For example, it lies in here. It is the point Q, and we have the triangle BQC. Yeah, BCQ and LKI. These two are similar, so we can transfer the angle KIL into BQC. So yeah, that's the first step. So when does the thing like triangle KIL is similar to triangle CQB? When does it hold? That only happens when AL here, AL equals to AL over AB equals to AK over AC equals to AI over AQ. So they all equal to 1 over 2. So yeah, we can easily get the similar triangles. So that's the first step. And we can know that I is the midpoint of the segment AQ, right? And the next thing is we have to turn the angle XPY into two interior angles of one triangle. So here we can notice this triangle. We can notice this triangle BQC. So we already have one interior angle, which is BQC, right? So we have to turn the angle XPY into QBC plus QCB. So our aim is the angle XPY equals to the angle QBC plus the point QC, angle QCB. Yeah, that's our aim. So yeah, according to the lines in the graph, we can find that the angle XPY is divided into two angles, smaller angles. So XPY equals to angle XPQ plus angle YPQ, right? YPQ. So if we take a closer look at the graph here, we might find that it seems like that these two angles are the same, isn't it? So if that holds, we must have another pair like these are the same. So what does that lead to? The angle XBQ equals to XPQ. So that leads to the 4 points. For example, we write as this angle XPQ equals to angle XPQ, and also, oh no, XPQ, and angle YPQ equals to YCQ. Yeah, that is equivalent to BXQP concyclic, and also CYQP concyclic. So that's our aim to prove that. So if we have this kind of solid, so we can connect these two segments, BP and XQ. So first we assume that these 4 points BXQP are concyclic. So what will we have? We will have the angle PBX equals to the angle XQA, right? So that is equivalent to angle XQA equals to angle XBP, and that equals to half of angle BAC, right? And what does that lead to? And it is equivalent to QX parallel to AC, and equivalent to FX cube collinear. That's the core of the problem. So in another way, in the same way, we can also find that we have to prove that Q, Y, E collinear. So we only have to prove one of them, and then we can get the same conclusion. Yeah. So how can we do this? If we also connect the points Y and Q, C and P, we can also find that the angle YQA equals to XQA. So QA is also the angular bisector of the angle XQY, yeah, and also we have so what we are going to prove that is we have these 4 green here, 1, 2, 3, 4. These 4 angles are the same, so we can prove that. For example, if we draw a perpendicular line through perpendicular line of AQ, and it goes through the point I, for example MN. If we draw this line, here the segments, we connect MQ and MQ. what will that lead to? Or cyclic or concyclic or cyclic. Okay, my fault. So we will copy another let's try it in the next page. So if we do this, like we draw MN and AQ, where MN passes point I. So yeah, so here the angles are all 90 degrees, right? 90 degrees. So according to the things we have, like for example, the points in IA equals to MIA equals to 90 degrees, and we have AI equals to AI and point angle NAI equals to MAI. So what can we have? According to the ASA rule, we can find that the triangles NIA is congruent to MIA. Yeah, that's very important, very important. So that leads to AM equals to AN. And also notice that MN So what can we have? MN is the perpendicular bisector of the segment AQ, right? So MN is perpendicular bisector of AQ. So that leads to MA equals to MQ, NA equals to NQ combined with AN that we have proved. So here it is equal. Yeah. So yeah, we have proved most of the questions. So now what we have to do is to prove that. Final mission, and FXQ collinear. Here we can draw a point. No, here yeah, we use the black pen. Here we can connect the points F and I. So it is easy to know that IF is perpendicular to the line FX, right? So here it is 90 degrees. And if we extend FI to AC, let them meet at, for example, a point of G. So since FX, like these FX and AK are parallel, so this will also be 90 degrees, right? So what can we prove? From this congruent triangles, we can have IN equals to IM, right? So I is also the midpoint of MN. Yeah, we have IN equals to IM point angle, and IF equals to angle MIG, and also IF equals to IG equals to the radius of the circle omega. That's it. That is because I is the center of the circle omega. So here are, and yeah, that it is obvious that F and G are the points of tangency. Yeah, so IF and IG are the radius of the circle omega. So what can we get? It shows that the triangles IFN is congruent to IGM, right? According to the SAS rule, side angle side, right? So the angle IFN equals to IGM here. IGM, it is also 90 degrees, right? So the angle in FX equals to NFI. Here we paste one more. We just copy one more time. Plus NFI plus angle IFX equals to 90 degrees plus 90 degrees equals to 180 degrees, right? Is that right? So that shows NFX collinear. In the same way, FXQ are collinear. So it shows that the 4 points in FXQ are collinear. And yeah, so also in the same way, M, E, Y, Q are collinear. Yeah, that's what we want. So here, according to our like just as we have analyzed before, these points collinear are equivalent to the points cyclic, right? So thus BXQP are cyclic. CYQP are also cyclic. What can we get from this circle? We can get angle XPQ equals to angle XBQ. It is just CBQ, right? And from this one we can get angle YPQ equals to angle YCQ. It is also BCQ, right? So angle XPY equals to XPQ plus YPQ equals to angle X just CBQ plus angle BCQ. Yeah, combined with with yeah, we have this kind of these pair of similar triangles. So we have KIL equals to BQC. So angle XPY plus angle KIL equals to CBQ plus BCQ plus BQC. That is 180 degrees. So we have proved this problem. That's all of this problem. Thanks.